In this video, we describe the development of small molecules as α-synuclein PET tracers. The entire development typically starts with organic synthesis. So once the organic chemists identify the best scaffold or chemical structure, they plan and then carry out multi-step reactions to synthesize the compound, and depends on how simple or complicated the structures are. The number of steps can vary from 1 to multi-dozens. Normally, the compounds synthesized are not pure but mixed with impurities, so the chemists have to purify them by various methods, including chromatography, as you see, or in certain other cases by recrystallization. The solvents contained in the compound are removed by rotary evaporation. The compounds then undergo characterization by NMR, HPLC, mass spectrometry, but the gold standard method is usually NMR because it allows the scientists to decipher the exact chemical structure. To evaluate biological properties such as KD and Vmax, autoradiography is usually performed. Autoradiography is an imaging technique used to visualize radioactive molecules on X-ray films, as you see. A detailed data analysis is then performed, which gives us more information on receptor-ligand binding. The most promising compounds will undergo radiolabeling for further testing. Usually the practitioners would start with hand synthesis of labeling to optimize the reaction conditions before moving on to automation. The entire development process is carried out in a carefully regulated environment where the scientists wear gloves, lab coats of multiple layers, as you see, since the scientists are dealing with highly reactive radioisotopes. For instance, carbon-11, fluorine-18, or tritium, which lasts from a few minutes to more than a decade of activity. The radio-labeled product will then put into a lead container and transported into the PET laboratory for further testing. Once the radiosynthesis is complete, the chemists perform quality control check of the radio-labeled product. This can be done by HPLC. The practitioners verify it by comparing whether the HPLC peak of the radio-labeled product corresponds to the HPLC peak of the reference. Afterwards, the PET scanning is performed on the tissue of interest, in this case the brain, when the radioactive molecules are injected into the animal, usually rat or mice. Here what you can see is how the practitioners detect the imaging contrast between uptake in the brain versus the reference, or in other words, whether the radioactive compounds can visualize α-synuclein aggregates in the brain. And to do this, there are various software such as PMOD, which not only allows visualization but calculation of pharmacokinetic parameters, or how the compounds distributed in the brain or in other regions over time. Thank you for your watching.